Good morning. I am Dr. Mehajabeen Fatima from Sagar Institute of Research and Technology. Today I am taking experiment of control system lab. The experiment is a step and impulse response of first order system. So the time response of the first order system, step and impulse response of first order system. So you can see here, this is the first order system where you can see this is the block diagram of the first order system. R is representing input, Y is representing output, 1 by tau S is representing the transfer function of the forward path, and 1 is representing the unity feedback, or the transfer function of the feedback path is equal to 1. So if the transfer function of this first order system is calculating, then we can say if the transfer function of this control system is calculating, then this is equal to 1 upon tau S plus 1, where the tau is the system time constant and it characterizes the speed of the response of a system to an input. If unit step function is given, what is the speed of the system? If impulse of the system is given, and what is the speed of the system? This is decided by this tau. Higher the time constant, slower the response, and vice versa. This is the impulse response of the first order system. If impulse input is given to this system, then the output is looking like this. The output is going to reduce with respect to time. This is the impulse response. But if the step input, unit step function is given to the control system, first order control system, then the output will be looking like this. The output is going to increase slowly with respect to time and it reaches to its steady state. So moving on to the program. So I'm taking here MATLAB, online MATLAB I am using. For this, write MATLAB online. Click on this. Now click on MATLAB. So start the new session. This MATLAB is available online. We can do the simulation work online. The license version is not required. So now I'm going to draw the step and impulse response for the first order control system. So consider a transfer function. I'm considering the transfer function equal to 10 upon, this is equal to 10 upon S plus 10. So I'm writing here, let it be A equal to TF. TF is used for the transfer function. TF is the command for the transfer function. So I'm writing the numerator coefficient and denominator coefficient within a square bracket. So see, you can see here, this TF is using for the transfer function, and within a square bracket, here this 10 is written for the coefficient of the numerator polynomial, and 1 space 10 is written for the coefficient of the denominator polynomial. Now enter. So you can see this gives a transfer function of 10 upon S plus 10. So for this particular transfer function and for this particular first order system, I want to draw the step and impulse response. So first I want to draw the step response. So I'm writing X equal to step, within parenthesis write A is the variable of the transfer function, this transfer function. So I wrote here X equal to step. I put semicolon here since I don't want to see the results, only just I want to execute this command. Now this is executed. Now I want to plot this step response. So now with this command you can see the output is available. See, What is the output? Again, I'm going to plot this one. I hope this time available. Yes, now this is available. You can see here, the unit step function is given to the system, and output, you can see this is going to increase slowly and reaches to its steady state. So this is the response if the step input is given to the first order system. Now I want to I want to plot the impulse response. For this purpose, first I'm going to calculate the impulse response. So write the command impulse within parentheses, write A, the variable of the transfer function, put semicolon. Now this calculated the value of impulse. Oh, yeah, this one. So see, here the value impulse is calculated. Now I want to plot this impulse response. Now say this is the impulse response. So this is going to decrease with respect to time. So if impulse input is given, the output is somehow like this for the first order system. If I want to watch both the figures, step response and impulse response, then I can use the subplot command. So I'm writing here subplot figure number 1. Two plots I want to draw. Now the figure which I want to plot, let it be at number 1. Then plot X. So you can see this is going to give a plot. This is the step response. Now I want to plot the impulse response with the same figure. So I'm using subplot command. Now write plot Y. So this is going to plot the impulse response also in the same plot. Plot Y. So first there is some error. So I'm writing here Y equal to impulse of A. This is going to calculate the value of impulse. Now here it comes impulse value. So now I want to run this command. Okay. Okay, I got the problem. Since I'm not writing correct spelling of plot, that's why this is giving error. Okay. Now this is going to give the plot. Yeah. So you can see this is a step response and impulse response. Now this explains the how can we plot the step and impulse response on the MATLAB. Now this completes this lecture.